So let us start with the question number 6 today. So which of the questions following? So which of the following are the correct statement? Correct statements. Right? So let us take the statement 1, or even say A, which says the wave function psi must be finite, continuous and single valued at every point of the space. Must be finite, single valued and continuous at each point of the space. At every point of the space, right? So, and then the statement B is both x and cos, both sin x and cos x can be wave function. Can be wave function. Right? C is the position probability density mass square must be greater than or equals to 1. Right? And the fourth one is that the state for which the probability density is constant in time are called stationary states. Right? So we have to find out which of them is the correct statement. So let us go to the first one. The wave function psi must be finite, single valued and continuous at each and every point of the space. So you know that this is the property of wave function. So it must be unique, so, and it should be finite, right? And single valued, obviously, right? It cannot have multiple values at any one point of the space, and it must be continuous everywhere, right? You can recall the boundary condition which you use when you are solving for the particle in box or potential well or any other problem. So you always use these conditions: finiteness, single valuedness, and continuity, right, of the wave function. So this is true. Sin x and cos x can be wave function. So sin x, it is normalized wave. It must be normalized. If it is not normalized, it cannot be a wave function. So sin x and cos x cannot be wave function. Normalized form of sin x and cos x, where sin nx by L or like that, in normalized form, can be a wave function. Right? So this is not the correct answer. Simply sin x and cos x cannot be wave function. They must be normalized. Otherwise, if the integration is over infinity, and then it will be problematic. So you must have a normalized wave function. So if this, so if it is not normalized, it's not a wave function. Now position probability density must be greater than or equals. Now probability density cannot be greater than or equals to 1. It must be less than or equals to 1. Right? So probability density integrated over into entire space. Entire space will give you the total probability. Right? Now, the statement 1 is correct, 2 is not correct, 3 is also not correct, and the fourth one, the states for which the probability density is constant in time are called stationary states. Right? So that is true. You know that what is the definition of stationary state? Stationary state is the one for which the probability density doesn't depend on the time. So psi star psi, in this condition, you must remember the DET of psi star psi is 0. It means that it doesn't depend on time, and it means that the state is stationary. Right? So this is so the statement A and D is correct. B and C are not correct. Right? So now let us go to another problem. The problem number 7. Now problem number 7. So here the problem number 7. The wave function not the wave function, the function, to the function gx equals to ax e to the power minus x square by 2 in the is the eigenfunction basically. With the eigenfunction function of an operator O cap, which is a minus of d dx square plus x square. Now it is asked to find out the eigenvalue. Right? Then the eigenvalue of the operator when operate on this function will be. So the eigenvalue of operator when operates right. So this is the question. Now let us solve it. So what is simple method for solving it? just operate O cap on Gx, right? What is this eigenvalue operator, eigenfunction, and eigenvalue relation? So operator O operating on any eigenstate psi give you some lambda multiplied by psi. Where O is operator, psi is eigenfunction, and lambda is eigenvalue. Right? So this is there. So now let us solve it. So here psi is nothing but G. Lambda times Gx. Right? So just put it there and Gx. So it gives you minus of d dx square plus x square operating on ax e to the power minus of x square by 2. Right? Equals to lambda time ax e to the power minus x square by 2. Right? Now let's simplify it. So when you simplify it, you will take minus out and then ddx of ddx operating on ax e to the power minus x square by 2. Right? Obviously a is out. Right? And plus x square. So it gives you which is equals to a, and then this ddx of x is 1. So it gives you x e to the power minus x square by 2. Then again, what is the differential of x? This e to the power minus x square by 2. It is e to the power minus x square by 2, and then differential of minus of x square by 2, which gives you minus of 2x divided by 2, which is x. Right? With minus e to the power minus x square by 2. Right? And then minus of ddx operating on this complete plus x. Now when you again operate it on, what you will find that it gives you a multiplied by the differential, which gives you minus of 1. Right? When you differentiate with respect to x, and then again minus because of this, and then x, and then differential of minus of e to the power minus x square by 2, which gives you minus x. Right? And then differential of this, which gives you minus minus and plus, right? This gives you x square as 2x e to the power minus x square by 2, right? Here also it is. Gx is there. Right? But Gx is the big line, right? Minus this, how much it is? 2x into minus x. Sorry. Yeah, minus of x square into minus of x is giving you x cube. Right? And then plus x square times it gives you a x cube e to the power minus x square by 2. Putting gx here, right? Now if you look at it very carefully, a multiplied by this, right, with one extra minus sign, so this is giving me minus, right? And two x minus sign, and this is plus, and then again this is minus, right? And then this is there, so this and this cancels out. Here a is there, right? And you are left with x this is not correct, right? Because it is differential of x gives you x e to the power minus x square by 2, so gives you x differentiated, then e to the power minus x square by 2, right? So e to the power minus x square by 2 is the one term, and then another term will be x into minus of x, this term, right? Now when you again differentiate it, you will have this as differential of this will give you what? It will give you minus of x e to the power minus x square by 2, right? And then differential of this x and minus x as minus of x square, right? Which is giving you minus of x, right? And then, and this becomes plus. So this gives you minus of x square, giving you 2x, right? With a positive sign because of this minus. So 2x x to the power minus x square by 2, and then third term will be this. So this is not there. The third term will give you this term. Right? So it gives you what? Cancelling out all the terms. Obviously a is multiplied here. A. So this cancels out with this. So what you are left with is a into 3x into the power minus x square, right? Which gives you 3 times gx. Comparing it with the lambda x, lambda is, so you can see that eigenfunction, if this function is eigenfunction of this operator, then eigenvalue corresponding to that will be 3. Right? So it's a simple problem, but with a little bit of calculation, which you need to do it carefully. Right? Now we will go to another problem, problem number 8. So just note it down. We will go to problem number 8 now. So problem number 8 says So let us discuss this problem number 7, which talks about the Compton effect. So it says that if photon of wavelength lambda equals to 0, 8.414 nanometer collides elastically with an electron initially at rest, right? If the photon is scattered at an angle of 60 degrees, with the wavelength lambda dash equals to 0.4152 nanometer, then find the angle at which the electron reconcile, right? So this is a simple experiment. So electron is here, and this photon is falling on it. This is your wavelength lambda, and this photon is going with a lambda dash with some theta, and then electron is going with some phi, right? The lambda dash is elongated wavelength. This is an inelastic collision. Some of the energy of the photon goes to electron, and that's why photons energy is decreased, and it moves with this wavelength. Engaged wavelength. So you know that there is a formula which says lambda is how much? 1414 nanometers, and then lambda dash is 1415 nanometer, and theta is 60 degree, and phi is asked, right? So relation between theta and phi is cot phi is 1 plus h nu divided by M.Sc square into tan theta by 2 with the one relation, right? And another relation is the usual Compton effect relation, which is lambda dash minus lambda equals to h by M.Sc 1 minus cos theta, right? So first relation, what does it gives you? So lambda dash is given as 1415 nanometer, and this is 414, right? And this gives you h divided by M.Sc 1 minus cos 60. What is cos 60? Cos 60 is 1 by 2. 1 minus 1 by 2 is 1 by 2. So it gives you giving you 1 by 2. So it is h divided by 2m into c. Right? So this is there, which is equals to 0.0012 nanometer. It implies that h divided by m into c equals to 0.0024 nanometer. Right? So this is something which you have found in terms of lambda and lambda dash and theta. Now let us calculate cot phi. So cot phi is equals to 1 plus h nu is c by lambda into h divided by M.Sc square. C cancels out, tan 30, right? So what does it gives you? It gives you 1 plus h is how much? So what is lambda? Sorry. So lambda is here, h divided by M.Sc is how much? This much. So h divided by M.Sc is 10024, right? And lambda is given as 1414. These are all in the nanometer. Into tan 30 is 1 upon root 3. right? So you just simplify it. When you simplify it, you will get something like 1.58, and this is 1.732. So you need to verify it, because this is not 48, this is 2. So you 2, 4. So this you have to match the zeros. So it will be giving you 24 divided by 4140. Remove the zeros, right? 24 is 12, and this is 41. How much? 2, 1, 4 is 7, and 0. Right? No, that is not correct. 2070. Right? 2070 and 12. Further 6, 1035. Then further, you need to simplify it. To get the correct answer, right? So this should not be 5.8, it should be very, very less value, which we need to check. 1.0058. Here we 1.732, which gives you nothing but 0.579 something like that. This is 5.8. Which gives you 5 as cot inverse of 0.579. So 18 and 5 should be 85.8 or something. This is nearly equals to 60. I will take it. It is so this is all we have. So let us record what we did right now. So problem was given that a photon is falling with a wavelength lambda and striking with electron, which is at rest, and the photon is moving with a elongated wavelength lambda dash and an angle theta equals 60 degree. It is either what is the inequal side angle of the electron? Phi. So lambda is given, lambda dash is given, theta is given phi. Now we will use this relation between lambda and lambda dash to calculate your this value h divided by m naught c, which is this much. Energy of the second lowest state of polytronium. Is how much? Solution is here. First we should try to understand what positronium. So positronium is basically a set, an atom, a atomic structure which contains two particles, electron and positron, and it's an unstable structure. It is something like this. One electron is here and one positron is here. Right? With no nuclei. So center of mass lies somewhere in between. So their mass will be basically the 1 upon mu equals to 1 upon m1 plus 1 upon m2, which is 1 upon m plus 1 upon m. Both are equal masses charges. It gives you 2 m. It's implying the radiated mass mu is nothing but m by 2. Right? So you see m is nothing but me, obviously. So its mass is reduced. So it is just half of the mass of electron in one electron atom. So its energy will be half of what is the energy of an electron in one electron atom like hydrogen atom. So energy E will be minus of 13.6, right? Divided by n square into. So what does it contain? If you remember, it's actually the formula contains me into E square. Divided by 32 pi square epsilon naught square z square n square. So this is the usual formula which gives you, with all these constants, minus of, including me, gives you minus of 13.6 divided by n square. Now here me is not, here me dash is there in this case. E is me dash. Sorry, it is mu, right? Which is me by 2. So in place of me, you will write it mu, right? So mu is how much? It is me. What its solution is? It is me divided by 2. So this will be giving you 2 times n square, right? This is the formula. En for the positron. In place of me, you replace mu. So this is 30.6 divided by 2n square. Now in this second state, second lowest state, not the first. Now ground states, first state, second state. 0, 1, 2. So n equals to 2. How much it is? If you remember 13.6 divided by 8, it gives you minus of how much? It is 1.7 electron volt. So this is the energy of positron in E equals to 2 state. This is a simple result, right? So it's unstable structure is there with electron and positron, and then the radiated mass is there and the energy. Now let us go to the problem number 10, right? Nuclear production, right? In the process to make away some of the photons momentum. Right? So it is not make up, it is take away. Right? However, a pair annihilation process, energy and momentum can simultaneously be conserved without any additional field or mass such as nucleus. However, in pair annihilation, annihilation process, energy and mass. Mass, not mass, it is momentum. Energy and momentum can simultaneously be conserved. Be conserved, right? Without any additional field or mass such as nucleus. Without any additional field or mass such as nucleus, right? It is asked that whether this statement is true or false. So the answer is false. Just analyze it. You can look into the pair annihilation production in Arthur Weiser, the modern physics book. It's a very nice book. You can look into it. What pair production, pair annihilation. Pair production, massive objects such as nuclei. So pair production is what? A single entity is there which is breaking into two parts, right? So a pair of particles, particle, antiparticle or something, they produce, right? It's a process. And so to conserve the momentum, as one particle is going into two particles, conservation of momentum is required, which is done by taking some momentum by nuclei. Whereas in pair annihilation, what happens? The two particles just colliding and they are going into one particle. So it is more like an inelastic collision, and in that case energy and momentum, it is more like an elastic collision, and their energy and momentum can be made conserved without presence of any external nuclei, right? Any field or mass. This statement is true. You don't require any external field or moment mass for conservation of this energy and momentum in pair annihilation process. So answer is true, right? So this is all we have in today's lecture. We will further come up with more number of problems. These are the basic ones. Now we will go to the actual start the quantum mechanics from the next class. So here now one erratum is there, or one correction. In the problem number 3 in the previous class, question 3, the answer which I just dividing by 6.63 divided by 9.1, I wrote simply 6.9, which is not correct. Right? It is 0.69. So in that way, when you will get the answer will be 6.9 nanometer. So just correct it, not the 69 nanometer, not 69, which I wrote there. So 6.9 nanometer is the correct answer. So just make it correct, right? So this is all we have in today.